Okay, we are reviewing slope-intercept and point-slope forms in our next chapter in geometry. We're going to be doing a lot with lines and parallel and perpendicular lines, so we need to review this information. So the first problem you had this week says find the slope of a line, and they give you a different one. This time we're going to have the equation negative x minus 2y equals 6. You might remember from Algebra 1, this is standard form. And we want to get this into slope-intercept form, which means we isolate the y. So first, I'm going to add x to both sides. And you get negative 2y equals x plus 6. Yes, you could write 6 plus x, but we want to get this in slope-intercept form where we have our x and then our constant term. Now I'm going to divide everything by negative 2. So since there's two terms over here, I need to divide them both by negative 2. Y equals, this becomes negative 1/2 x plus 6. So when they said find the slope for this, the slope would be negative 1/2. If I wanted a line parallel to this, anything that has a slope of negative 1/2 would also be parallel to the line formed by this equation. And if I wanted anything perpendicular to this, I would want the negative reciprocal. So that would be 2 over 1. Since this is negative, the negative reciprocal is positive, and the reciprocal is 2 over 1. So if I had anything with a slope of 2, that would be parallel. You don't need that for this problem, but I think it's important to mention it because you will need that in problems in this chapter that we'll be getting into in geometry. So our second problem is write an equation that describes a line in slope-intercept form with a slope of 2 and a point of negative 1, 2. There's actually two ways to do this. You could put this into point-slope form since you have a slope and a point, and then work it into slope-intercept form. Or you can remember what slope-intercept form is y equals mx plus b. I know that my slope is 2, and in this problem they're telling me that the x value is negative 1, and the y value is 2. So I need to find the y-intercept of this equation. In order to write it in slope-intercept form, I need the slope and I need the y-intercept. So 2 equals negative 2, 2 times negative 1, plus b. If I add 2 to both sides, I get that b is 4. So now I know my slope is 2. They told me that. My y-intercept is 4. So once again, y equals mx plus b. I erase the m. I put in 2. I erase b. I put in 4. And y equals 2x plus 4 is the equation in slope-intercept form. Number 3, write an equation in point-slope form from the equation of the line, for the equation of the line, with a slope of 2/3 that contains the point 3, 1. So the slope formula, the point-slope formula is y minus y1 equals slope times x minus x1, where your x1 and your y1 are just your ordered pair in your first point. In this, your ordered pair of your first point. In this case, they only gave us a point. So y minus 1 equals 2/3 for the slope, x minus 3. And that is the equation in point-slope form. We could, separate problem here, guys, but we could put this into slope-intercept form by this is 2 thirds x, and 2 times negative 3 is negative 6, divided by 3 is negative 2. Add 1 to both sides, and y equals 2 thirds x minus negative 2 plus 1 minus 1. So once again, this is the answer to this problem, but I've heard kids in class talk about the fact that they don't understand what it means to write it from one form to another. That's what we're doing. We're moving these pieces around so that we isolate y so that we have an equation of what y is equal to. So for number 4, they want to know which lines are parallel. As we talked about before, parallel means they will have the same slope. So this has a slope of 3/4. This one is in standard form, so we don't know that yet. This one has a slope of negative 3/4. And this, even though it's not in slope-intercept form, it's in point slope. And so I know that that is the slope of line 4. So I need to take line 2 and go ahead and get it in. I'm going to go to slope-intercept form, and that'll help me find the slope. So if that way I can find the slope. So subtract x from both sides. I have negative 4/3 y equals negative x plus 9. I really do not like this fraction here. I don't want to start dividing by the reciprocal. So I'm going to clear the fraction. Hopefully you remember this trick. Now multiply everything by 3. 3 times negative 4 is negative 12. Divided by 3 is negative 4y. 3 times, this would basically be like a negative 1, negative 3x. And 3 times 9 is 27. Now I'm going to divide everything by negative 4. And really, since I want the slope, all I'm really looking at here is that negative 3 divided by negative 4 means the slope is 3/4. I'm not even going to worry about this 27 divided by negative 4 because it doesn't affect me. So line 2 actually has a slope of 3/4, which means that line 1 and line 2, and actually use the parallel line symbol, are parallel. It also tells me that negative 4/3, that line 4 would be perpendicular to line 1 and line 2 because these have a slope of 3/4. The negative reciprocal is 4/3. They didn't ask for that in the problem, but I do want to point that out to you. Write an equation in slope-intercept form of the line parallel to y equals 9x minus 3 that passes through this point. So once again, I have a slope of 9. Before, I would have put in negative 3 for each of these. Actually, I think I'll do that again this time. So y is negative 3 in this problem. X, I'm going to resolve this, is negative 3. The slope is 9. And then I need b. So negative 3 equals negative 27 plus b. When I add 27, I get positive 24 equals b. So the equation that is parallel to this is y equals, once again my slope is 9x plus 24. Remember, here I'm finding the line that has a slope of 9 and goes through negative 3, negative 3. When I say I want it in slope-intercept form, I want where it's going to go through the y-axis. That would go through at 0, 24. That is my y-intercept. And you can check that. If I plugged that in, 9 times 0 is 0, plus 24 does equal 24. So I actually could check the equation right. Okay, there's a trick here. X minus h plus k. You have to do no math here. So I just threw this in here. I thought it was important. When you're looking at absolute value equations, this is the default or the parent formula. So your h value is your x value of the vertex. Your k value is your y value. Actually, make more sense here. That's h and k. So in this, h is 3, k is 1. Now you want to be careful here, and it is set up to the defaults. It is, if this said x plus 3, since the default is x minus, the x value of the vertex would actually be negative 3. Since this is negative, it's positive. Default here, plus k. So my vertex is 3, 1, and they want to say whether that's a minimum or a maximum value. So I know that this is going to go through 3, 1. I know it's going to open up because this slope here is positive. So this is minimum value. Yes, absolute value equations are really that easy if you understand this parent function, absolute value of x minus h plus k. So just to give you another example real quick, let's say you were doing y equals, I'm just making something up here, let's do negative 4 x minus 5, x plus 5, let's do this, minus 2. So since the parent function is x minus h, and this is positive, it'd be negative 5. Since it's plus k, and this is negative, it would be negative 2. And since this is negative, it opens down, and so that's a maximum value. Once again, it doesn't pertain so much in Chapter 3 in geometry, but I've heard kids in class mention that they don't remember this or weren't sure about this format, so I wanted to include it in the ridge review. Number 7, draw and label a pair of opposite rays. I think this is the exact question that you have. Obviously, opposite rays go in opposite directions. You need to label everything here, but they make a straight line. So I want this correctly labeled. Number 8, the measure of ABC. So this whole thing is 79. ABD is 35. They want to know what is the measure of DBC. So we're going to start with 79. We're going to subtract 35. And we are going to get that DBC, the measure of angle DBC, is 44 degrees. Number 9, BD bisects ABC. So ABD is 7x minus 1, and DBC is 3x plus 11. So we have, I might have set this up wrong, so let me draw it and make sure I understand what I'm doing here. So this is BD, and it bisects ABC. Okay, so it's ABD is this, DBC is this. They want me to find ABD. I think this is a typo. ABD is 7x minus 1, and DBC is 3x plus 2. They actually want me to find ABC. Since it's a bisector, that means it divides it in half. That's your vocabulary there that you would be expected to know. So these are equal to each other. I'm going to subtract by 3x on both sides. I get 4x minus 1 equals 11. I'm going to add 1 on both sides. 4x equals 12. So x equals 3. Oh, I see, it wasn't a typo. They want to find the measure, of ABD. So 7 times 3 is 21, minus 1 is 20. And let's check that. DBC should also be 20. 3 times 3 is 9, plus 11 is 20. So the measure of ABD is 20 degrees. See, at first I thought there was a typo, kept working through the program, and got it correct. Find the perimeter and the area of this figure. I think you had this question on Chapter 1 test. So to find the perimeter, we add up all of the sides. So 2x plus x is 3x, and then 4 plus 2 is 6. That's the perimeter. To find the area, we've talked about this, it's 1/2 base times height. But I would not take 1/2 of the base because of this x. And because I want to do this quickly and mentally, I wouldn't multiply and then take a half. I would just say, oh, 1/2 of 4 is 2. So that is 2x plus 4. 2 times x. I think I put parentheses in here that I didn't need to. It's getting tired on a Friday night. Sorry about that. 2 times x is 2x. 2 times 2 is 4. And that is the answer. Hope that this video helped you with your review of slope-intercept and point-slope form, as well as a few other assorted problems I've thrown in there. Have a great weekend.